In this video, I'll show how to set up a MongoDB sharded cluster using Docker. This is the setup I want to create with 3 config servers, 2 query routers, and 3 shards. I set up each shard as a replica set. You can set up a shard as a single MongoDB, but if you care about reliability, this is a better way to do it, and definitely if you're running a production environment. I created a script to set up my farm of 14 Dockers, so let's start that up. And while it starts up, I'll show you what this script does. It creates 3 config servers, and the config servers are used to store the metadata that links the requested data with the shard that contains it. I set up 2 query routers. The query routers are the machines that the Skycave connects to and are responsible for communicating with the config servers to figure out where the requested data is stored. And we can see the list of config servers as parameters. And then I set up 3 shards as replica sets themselves. The shard servers are responsible for the actual data storage operations. And in the end, to configure the shards, I created a JavaScript file which adds each of the replica set as shards. We prepared the database for sharding. I use point as a sharding key hashed in order to get better distribution of the data along the chunks in the shards. I tell that I want the room collection sharded. And in order to make the Skycave work, the only thing I had to do was, instead of connecting to individual Mongos or MongoDBs, I now connect to query routers instead. Let's see if it started. It's now started up, and as we can see, it added the 3 replica sets as shards. If we look at Docker PS, we can see we have 14 Dockers. There's 1 shard, 1 shard, 1 shard, and 2 query routers and 3 config servers. If we log into Mongo, we can see the default Mongo is the router 0. We can log into any router and get the same result. So if we switch to the config database, which holds information about the shards, we can see which collection are being sharded. We can see the chunks. The chunks are how the data is distributed along the different shards, and we can see the shards, and we can see the Mongos, the query routers. The best way I found out, or was thinking about, was to test this setup was to load the Mongo loader, which just digs a lot of rooms. So that's what I'm starting up now. If I instead switch to the CaveDB and look for rooms, I can see that I get the full data set of rooms. But if I instead log into the each individual shard, you will see a different story. Here we can see that now we are on the primary on the different replica sets. And if I do the same here, switch the Cave database and find, we can see that the data is actually distributed along these shards. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which shows that data is actually being distributed on shards. If we log into one of the query routers again, and we instead try to start the daemon and the client, which I'll do in a moment. There. And we switch to the CaveDB again. On the query router, we look for a room with Jule in the description. We find nothing. If we then try to dig a room and run the same regular expression find again, we will see that a room is actually now produced. That should show how the sharding works, and also in a replica set, which is quite awesome. There.